Anything? Okay, right. So today we will have a lecture on data structures and algorithms beyond classroom by Kumar Shubham, who is working as a software engineering at App Dynamics. So before he starts, let me introduce him. He got graduated as a computer science engineer from VIT Chennai in the year 2019. And during his college days, he was passionate about problem solving, working on projects and open source technology. To mention a few, he got rank 12 on site programming contest in TechFest hosted by IIT Madras, secured silver medal in HackerRank World Code Sprint 13, and got a first prize on first day for presenting a cloud navigation system. He was selected for Google Summer of Code in the year 2017, and he worked on a project at Berkeley Client Center at Harvard University. He done internships at PayPal and Wignify also, and he was also part of our vPrepal team. He designed and implemented the students login and problem of the day modules of vPrepal. He has given many questions for the problem of the day as well. In AppDynamics, he has worked on projects that dealt with automation tools and integration, agent leak, agent memory leak, Kubernetes, and performance improvement. Currently, he is pursuing his MTech in data science and business analytics at IIC Bangalore. I think I can hand over the session to Kumar Shubham. I have made you already as presenter. Can you please check and start the session?
Sure. Thank you, ma'am. Am I audible and is my camera working fine? Just wanted to check.
Yes, yeah.
Okay. Let me just share my screen. Is my screen visible?
Yes.
Okay. Cool.
Okay.
Hi, everyone.
Others should
Yeah.
talk. I'm going to mute myself.
Okay. So hi, everyone. Thank you, ma'am, for that introduction and thank you for all those words. And hi, so as ma'am said, I have graduated from VIT Chennai, and I've been in the same classes that you guys are right now. So the main goal of this guest lecture is sort of to motivate you to think of this subject as not something to study for just passing your grades or just sitting in these labs to get attendance, but to actually show you that whatever knowledge that I gained through these subjects, it's still useful in the present days. Obviously, not someone is not giving me marks for implementing these solutions, but definitely whatever knowledge I gained through this subject is definitely helping me maybe clear interviews, and after clearing interviews, it does help me in my day-to-day work. So today I have just picked up some of the examples that have come up in my day-to-day job. Some of them are from my experiences, some of them I've read online, but I'm trying to share with you guys so that I motivate you to uh, pay attention to this subject and understand how important this subject is to if you are planning to become a software engineer. So let's get started, and we'll have some time for Q&A in the end as well. But if there's something important that you want to ask, you can pause and ask me in between. Okay, so let's start. Um, so as you can see, I have matrices, recursion, tree, dynamic programming. These 4 topics I've mentioned here. So these are all the topics that I have faced in my experience till now, and I'll just talk about what was the problem that I faced and how I solved them. So let's get started with the first one. So this one involved machine learning, and machine learning, as we know, deals a lot with matrices, right? So let me see if this works. Yeah. So this was the first problem. So the first problem was predict potential memory leaks in an application. Now, just to give you all a context what a memory leak is. So let's say you have your program running in your computer, right? And sometimes you see that in Windows you get application crashes. So one of the major reasons for an application getting crashed is a memory leak. A memory leak means that the application was using so much RAM, that the operating system finally decided, I'm not going to give you more RAM to run. I'll just make you quit. So one of the potential reasons for application crashes. So our product in App Dynamics, we give users a product, and if that product itself is causing memory leaks, that's a big shame to our company, right? So I had to design an application that could just basically run and observe our application, and see if there are some classes in that application that are leaking memory. So that's the problem statement basically. So let's get into how the problem is and what do we get. So the product that I'm talking with is written in Java. So Java programs, they run in a JVM, Java Virtual Machine. So what data we are working with here is, so let's say I have this application running for a very long time, let's say 8 hours to 10 hours, because I need to run it for a long time so that I can analyze what is the memory usage pattern of this application. So I let it run for a very long time, and let's say at every 5 minutes interval, I do a profiling of this application. By profiling, I capture a heap dump of this application. Now, heap dump is basically a file where I just get the class name and comma the memory usage at that current point of time. So I take heap dump of that class regularly. Now with this data, let's say I run it for 8 hours. Now I have 5 minutes of I have data with granularity of 5 minutes. So in 1 hour I collect 12 data points. In 8 I'll have 96 data points. So on these 96 data points, now I have to find out what all classes are there in this file that could be potentially memory leaking, right? So let's move ahead. So as I said, right, this is the structure of a heap dump. You have class name and you have bytes used. So if you could see just a sample representation. So I have a class name com.appd.hashmap, and this is the size memory being used in bytes. Then you have, let's say, java.util.linked list 1 2 4 5 3 bytes. So having this kind of data set, I had to kind of predict which of these classes could be leaking memory potential. So the answer that comes in my mind came in my mind at that point of time was, why not try linear regression to fit a straight line through these points and see what's the slope of that line. Right, we have all like kind of studied straight lines in mathematics. So a straight line, depending on the slope, I mean the angle at which it crosses the origin or the x-axis, it gives you its slope. So if the slope of that line is very high, which that means that the memory footprint has been growing very, like, if it's above 45 degrees, then it's obviously a very big thing. So if some of you who already done machine learning and know about linear regression, you must be knowing that we use linear regression to given data points, we can fit a straight line and get the slope of that line. So I use the idea of linear regression, and this is just a schematic representation of how linear regression looks like, right? You have these coefficients beta 0, beta 1, and so on. So I use linear regression to solve this problem. So another cool example of something that you're reading in your classroom. Now, linear regression is a topic that you all know, but beneath it uses matrices, right? So if you can see, these are just matrix operations that it'll be doing. So if you just quickly talk about the matrix algebra, or the linear algebra inside this. So we have to do a lot of matrix additions. We have to do matrix multiplications. We have to do inverse of a matrix to basically find the pseudo inverse, or invert the matrix to find the solution of a system of equations, right? So there, these matrices are very heavily used. So I'm sure when you prepare for interviews, or when you have, like, in your classrooms as well, you study problems based on matrices and you feel this is too heavy. I have to run two loops and multiply two matrices, but it has practical applications. Now, obviously, you'll not have to implement everything on your own. It will be based on the libraries, but having experiences of all these things helps you in understanding what to choose, when to choose. So, for example, in this case, having studied linear algebra and having knowledge about that, it uses matrices and everything. So in Java, I did not have like all the libraries as easily available as they are in Python, right? So you do have to implement some things on your own. So that's how having knowledge of these things helps you to find out what is to be needed at what place and how it can make things easier. And last point, I've written faster algorithms. So here comes the knowledge of the knowledge of algorithms. Here it comes into the play. So let's say you know only one way of multiplying matrices. Now, matrix multiplication is, I think it's done in n cube. I'm depending on mn, and I'm assuming all of the matrices are the same size. It's done in big O of n cube time, let's say. But there are other algorithms as well who can, depending on matrix conditions, do this multiplication faster. Now, if you have covered, or if you just know about these things, it's better for you, right? When you're actually solving the problem at hand, you can just recall, okay, yeah, I did read something about this. Let me just go and take a look at it, and you can solve the problem quicker. Nobody asks you to just remember everything, but going through it in the classroom definitely helps you to remember it so that you can recall it at the right time, right? So moving ahead, any questions here?
No,
And
sir.
guys, please make yeah, thank you. And please make it an interactive session. Don't make it as just me talking and you guys not responding, because this is, again, this is something that I've faced in real life. It's not something that I'm talking that I saw it in a book or I'm just narrating to you. So Feel free to ask your questions. Feel free to, post your thoughts and we can have a discussion. It'll be good. So continuing from here, uh, so let's talk about another great important topic that we all study while studying algorithms, that is recursion. So could someone just quickly tell me what recursion is?
Calling a function inside a function, inside the same function.
Yeah, inside the same function being the key. If you call another function inside a function, it's just a function call. Cool. Thank you, Devan. Thank you, Devansh. So that's what recursion is. Now, is there a popular problem or anything that you have solved that involves recursion? Anything? Anyone can give me an example of a problem that you have solved that involves recursion?
Merge sort.
Merge
Sort
sort.
button.
Yeah. Merge sort is a very good example of a recursive algorithm. Good. All right. So moving ahead. So I want to talk about a practical application where I use recursion, where recursion can be used very much often. Now, I've written this line: consuming REST APIs can involve the use of recursion very often. Anyone knows what REST APIs are? Heard the term REST APIs? Anybody? Anybody, please go on.
I
If
mean,
you just have an idea. Yeah.
Yeah, from my understanding, REST APIs is a format of defining APIs that you can call over a standard format for defining APIs so that everyone can use them.
Yeah. Yeah, that's correct. So REST APIs are stands for basically representational state transfer. So basically what we got the answer, right? So it's a standard way of defining API. So there you must have heard some things like GET request, POST request, patch requests, things like that. So GET means an API is supposed to return you some data. POST means an API is designed to make to update some kind of data, and similarly, right? So uh, so this is what REST APIs are, and so I've written that consuming these REST APIs can sometimes involve recursion. Let's see how. Let's see the problem statement where I use them. So yeah, so I'll just quickly read this and then I'll explain to you in more detail. So I've written here that let's say you are given a REST API that returns a list of 1,000 entities and returns a continuation URL if there are more than 1,000 entities in the response. You can make a GET request on this continuation URL to get next 1,000 entities. Write a method that fetches all the entities that are present. All right. So yeah. Okay. So what I mentioned here is, let's say we have a REST API that returns. So you just make a GET request at some website and it returns you some 1,000 entities or a list of some 1,000 strings. Let's say it returns you that. Now, if there are more than 1,000 strings available in the database, it will return you another URL, and you can make another request on this URL to get the next 1,000 entities. And let's say if there are more than 1,000 entities, it will keep on returning you this continuation URL as long as as long as you have more than 1,000 entities, the continuation URL will keep on coming. So do you think that there is some kind of recursion here or something like that is involved here? Or first of all, do you understand what I'm trying to say? Do you understand the problem here?
Yes. Let's say there are more than 1,000 entries. I can just have n number of pages, that each page having 1,000 entities, and have a button kind of stuff that actually takes you from one page to other to other to other. Why is recursion involved? I want to ask.
Exactly. So this is all good if you are doing it on a web page, right? If you want to design something that can use a button. What if you are working somewhere what if you are working on a backend that doesn't involve having a web page?
Would using a while loop be a solution also? An infinite while loop, as in like while a continuation URL exists, call it.
Yeah, so exactly. So that's also a perfectly valid solution. So you have written, right? You have seen recursive program being written as iterative algorithms many times, right? That's obviously a
Yes.
perfectly valid solution. But do you see that we can also solve this using recursion?
Yeah.
So basically, I mean, I'll just keep on going. So do you see the recursive nature here? And we do see that. So, you just keep a list to store all the entities, make the first. So again, we are doing this in an environment where we don't have access to like clicking a button and then making another call, so on. So think of so that's what. So you might have scenarios where your standard ideas, you might have to think, okay, I cannot do this, because your button solution is perfectly valid if you're doing it on front end website, because you just don't need to care about recursion or anything. It's a new page, new request, perfectly valid. So make the first call is continuation URL present. If yes, then recursively call a helper method and keep, or you could use a while loop where you could just set the continuation. But the thing is, in production systems where you have things running, you prefer not to use a while loop in such a way, because see, so I did this in a solution where Node.js was running. So if some of you who have experience with Node.js would know that it has an asynchronous nature. So you could just run things background, like in an event loop. So it's not, so if I use a while loop, it will just block my application there. It will wait until all the application, all the entities are fetched. And let's say if there are, let's say 10 per 5 entities and 1,000, it's going to take a lot of time and my program is going to get stuck for a very long time. But using recursion, I could just use promises to let that run in the background event loop and not let it block my main execution thread. So just a little bit of detail there why I use recursion there. So using while loop is perfectly valid solution if you're writing a program that has to run for a while. But sometimes you do have to evaluate if can you run while loop in the system or not. Not everywhere it's suitable to run while loop. Do you understand what I'm trying to say? Is uh, it's fine while loop, the iteration algorithm is totally correct, but it's the environment which limits us from running it.
Yes.
Right. So that's why we had to use this. And again, so we just keep doing this. So so recursively, we just keep calling our method until the continuation URL is null, or let's say it's not returned by the REST API. Right. So this is another example of recursion. So so far so good. Any doubts? All right. Take that as a no. So another very nice data structure and a very important data structure that we all study. So that's tree. So anyone can tell me what a tree is? Can anyone tell me what a tree is? Like you can use the term graph to define what a tree is, or just tell me what a tree is, whatever you know. Go ahead,
It is
whatever
a
is in
graph
your mind.
built in a
Yeah.
certain way.
Okay. Built in a certain way.
You have
Tree is
nodes
a
that are
directed acyclic graph.
Directed acyclic graph is a kind of tree. But does a tree always have to be directed?
no, it may not be actually.
It may not be. So a tree is basically a graph where there are no cycles and each node has only one single parent. What directed acyclic graph is also a tree. It has no cycles and it is directed. So that is also a tree. But that's a special form of tree in that the nodes, the edges are directed. And directed meaning that you can only go in one direction. So good. So this is one example of trees. So does anyone use Angular or React here? Anybody has experience with React.js, front end web development? Anybody? No one? Oh, you have.
Yes, I have experience.
Okay. I see a lot of people. Great. So you guys are doing a lot of web development alongside as well. Awesome. So you would have definitely heard that React, they always mention it has a virtual DOM. And it does all these manipulations on this virtual DOM and it re-renders in the browser. So heard about this term, virtual DOM?
Yes.
What a DOM? Can someone tell me what is a DOM? DOM? I'll just
Document object model.
document object model. So what's the structure of the document object model?
It's a tree of nodes, like
It's a tree
each
of DOM
element
nodes.
on the page.
Exactly. Correct. So, and we see why do we use React? I mean, okay, so why would you try to use a UI library like React? Why not just don't use anything, just straight up write JavaScript? What's the benefit of using a UI library like React? For those of you who know, for those of you who don't know about React and everything, I'll try to fill you up.
You'll end up writing lesser code in a more efficient way.
Yeah. Reusability of the code is existing. You can just reuse the components that you've used before.
Okay, yeah, that's a very good answer. So for all those who have not used React, just to let you know, so if you ever work on developing a web application, the language of choice there is JavaScript. So and when you website, you know that you write a website, the front end code of the website using basic HTML. Now this HTML resembles, and when this HTML runs inside the browser, browser has internally a structure known as DOM, document object model. And this document object model is basically a tree of nodes, and each of these nodes refers to your original HTML document that you created. So let's say if you click on a button and some new element is shown, and you click on a button and something disappears on the screen. So actually what happens when you click on that button, this entire tree structure that you have, the entire tree structure that you have needs to have some modifications, right? It needs to undergo some kind of modification. So when you click something, something is hidden. That means the browser has to calculate that, okay, I have to remove this node from the DOM and then present it to the user. So it's a very essential part of the web, this DOM, document object model, and it's a tree. So what I have written here is the problem statement. So this is like a very generic problem statement for all the modern UI libraries that we have, like React, Vue, Angular. So manipulating actual DOM is a costly and synchronous operation. Page load times are very important. So how do you always make changes to the DOM in an efficient manner? So let me just tell you what this problem statement means. So using a library like React obviously helps us to reduce the code that we are writing. It helps us to reuse the code that we have written already. But someone could argue with me that, okay, I could write functions in JavaScript that I could reuse. Then what's the added advantage of React in terms of performance? So in terms of performance, so as I mentioned, right, manipulating this actual DOM tree inside the browser is a costly operation. So libraries like React use something known as a virtual DOM. Virtual DOM. So as the name suggests, right, virtual DOM is basically a DOM which does not exist in reality inside the browser. It's something, a copy of the original DOM that React creates in its own memory. So it's basically like both the DOMs are running in memory, but this is a copy of the original DOM. So what do you think? So let's say I give you a virtual DOM and you have an actual DOM. How do you think you'll use the virtual DOM to do things in an efficient manner? So if you see in this image that I have shown here, this is the actual browser DOM. And I'll just quickly walk you through what these terms mean: state change, compute, def, re-render. But can someone who already is familiar with React tell me what this image is trying to say? It's just, I just want knowledge from you guys. What do you guys like want to share about React? Anybody? Don't hesitate. Don't be shy. It's okay. It's just our discussion.
State change generally refers to some change in one of the subchilds in the entire DOM. And I'm guessing compute difference is just comparing it to either the virtual DOM or whatever to quickly identify what the difference is to re-render. So if you have a change in like a counter or something, you'd want to increase it and display the new count on a website or something. So it was state change.
Correct. That's a very good example. So the state change. So basically, what state means in terms of React, and I'm not going into too much details here, but what state basically means is something that you are keeping track of, something that's part. So for example, you have learned C++, right? So let's say you develop you create a class named employee and you define some fields inside that class, the name, the salary or something like that. So these are all these values. When this instance is running in memory, these values make the state of that employee object that is present in the memory. So whenever something in the value of those fields changes, something in this field changes, in the case of browser, we need to do something. So for example, you have, as Shiva pointed out, right? We have, let's say, a counter that is being displayed. So there is a counter component that is running on our web page. And as soon as this count changes, we need to do something. We need to show the user the updated value of the count. So basically, if you see below, there's the original browser DOM. This is the original structure of the document object model tree that we have. So React, what it will do is it will actually not perform the modifications on the browser DOM until it's absolutely necessary. So what that means is, obviously, if a number, the counter has changed, then browser definitely needs to show it. But let's say in the background, while the counter was changing, React found out that there was something else that needs to be removed. Why not just club them all together, calculate the diff based on the previous virtual DOM tree that it had representation. Then here you again use algorithms to go walk down the tree, find out which nodes are different, replace those nodes, and then when you have finalized that, okay, this is the final structure that I want to render, only then and only then you modify the actual browser DOM tree. So this saves you from a lot of so this is a big performance improvement, right? If you would have written code on your own, I'm 100% sure you would not take the pains of implementing your own virtual DOM and so on. And obviously right now as well, you'll not implement your own virtual DOM because you'd be using React. But obviously there could be certain circumstances. Let's say you're running in an environment where, and I'm telling you that when you're in college, when you learn about things like React, it seems very much like you'll be using it in browser everywhere. But when you come to industries, there are there is a heavy chance that you might be dealing with React in an environment where you don't even have access to a browser. You could be running React on a server inside Node.js where you don't have browser. In that case, you need to have some kind of an implementation of virtual DOM, or maybe React is not something that you can use at all, but you need the same kind of performance. So there, having knowledge of these kind of things helps you to solve the problem faster. Obviously, you'll not nobody's going to ask you to implement a tree or virtual DOM on your own unless obviously there's the option. But most of the times having this knowledge definitely helps you to solve the problem faster. So that was the key takeaway from this one. And then last, but not the least, definitely we have to talk about dynamic programming. Now I assume it's just 7:05 right now, so we'll just talk about dynamic programming and some of the examples that I found. One of a very good examples I found out. I'll not go into much details about the solution of that problem, but I've linked an article where you can read more about that because it's sort of goes outside the scope of this current discussion. But anyway, so anybody who's first of all, can I see some hands on how many of you are afraid of dynamic programming? Can I see some hands? Okay. Just two hands. Okay. Yes. So only 5 people, 6 people, 7. Okay, go on. I'm giving you 10 to 15 seconds. Okay, so I'm seeing the number slowly increase. Okay. So any of you, yeah, okay, so I'm seeing okay, so the numbers are increasing quite fast now. Okay, you guys can raise down your hands now. It's fine. I get it. So probably like 1/6 of you or someone are, and probably more of you are afraid, but maybe not raising your hands. It's okay. So can anybody who raised their hands just tell me like what scares you the most about dynamic programming?
It's honestly identifying how you want to implement the dynamic programming part mainly. Like you'll have to figure out how you want to construct say a table or whatever required for each problem.
Okay. Can somebody apart from Shiva tell me, because Shiva has been answering a lot and I'm 100% sure you guys don't want him to answer everything. So can someone apart from, and Shiva, nothing from you, but I just want other people as well to answer. Thank you so much for answering by then. Anybody else? Why do you think other opinions on why do you find dynamic programming difficult? I'm sure ma'am would have taught you dynamic programming well.
Maybe trying to find like how we can, because like finding the variables that change and having like the for loops when we're trying to do like top down or bottom up like that.
Top down or bottom up. So okay, interesting. So the main problem in dynamic programming is to figure out how your current state will change. Like what will be the recursive equation? Like in case of Fibonacci sequence, it's very simple, right? We have f of n is equal to f of n minus 1 plus f of n minus 2, right? This is your state change equation. So agreed. I too face the same problem. I'm not gonna say that I'm an expert in dynamic programming as well, but what did help me, practice dynamic programming enough was plain and simple practice. So, in classroom, let's say I will just discuss this dynamic programming interesting problem also that I have here. I'll just go through it. But before that, I just wanted to have these quick words. So, uh, uh, definitely. So in class, let's say you start with longest common subsequence, longest increasing subsequence, edit distance. These are some of the very common problems that are associated with dynamic programming. But each of these problems has been solved in like is present on like n number of websites on the internet, and and this is a very common problem that used to happen, that okay, I'm able to solve longest common subsequence, but longest increasing subsequence is different. And okay, let's say I understand longest increasing subsequence. Oh my God, then I encounter another problem which is like entirely different from these two. So how do I find this common pattern, so that I'm able to understand the state change equation and how to build the variables, as someone pointed out, right? What are the variables that will be changing? So, and I'll be just blunt over here. It's just plain simple practice. So, summer before my placements, what I did was I just created a list of around 150 to 200 dynamic programming problems, and sort like use, there are a number of websites online. So I use these a number of websites to find out a list of problems, like 150 problems and so on. Sorted them out by the kind of pattern they are, or maybe used internet helps to find out the pattern they are broken in. Let's say I get 5 problems of each kind of, let's say there are problems of type LCS where it's much more easier to find the recursive nature. Then there are other kind of problems where it's not so easy to see the dynamic programming kind of overlapping subproblems and optimal substructure. So made a list of that and solved. Let's say if there are 5 problems in a category, solve 2 of them, understand how this category is to be done, and then take next 3 as an exercise to solve them on my own. Obviously, there are times you'll not be able to solve all 5 of them on your own. It's fine, you can use help, but using those 2 problems as a way to understand the theme of these problems helps you in building and solving those 3 problems. So if you solve, let's say, these 150 problems, pretty sure it covers most of the wide array of dynamic programming problems that you'll ever encounter. And I'm not saying that it'll cover everything all the time. You'll be able to solve the toughest problem there is on CodeChef that involves dynamic programming, but you'll pretty much be able to become a good problem solver where when you need dynamic programming, I'm sure you'll be able to link it to one of the patterns that you have already seen. And speaking of the pattern, here we'll just quickly talk about the problem and the pattern where, so this is from an article you would have heard about the company Share Chat. They recently hire a lot of people from CodeChef, cook-off contests and lunchtime as well. So by the way, does anyone take part in CodeChef contests, cook-off, lunchtime, long challenge? Raise hands.
Yeah.
Okay, nice. Good. How many people, like, do you guys regularly take part in CodeChef contests? Can I have a show of hands, please? Like, how many of you are aware of CodeChef and use it to actively solve problems? We had Devansh there for a minute. When. All right. 3 of you? Okay, cool. You can raise your hands down now. Okay, so partly, guys, one important thing I just wanted to point out is please spend time on these platforms. Anyway, I'll come back to it. We'll talk about after I finish talking about dynamic programming. I'll just dedicate a few minutes to explain to you the importance of problem solving and solving problems on these websites. Anyway, let's go on. So dynamic programming has lots of its uses in reinforcement learning as well, where I haven't taken reinforcement learning, I'll just be honest, but I have in the course syllabus and everywhere, and in my previous courses as well, I've seen in deep learning that when you go on for reinforcement learning, you need to know about there are ways where you have to optimize the agent and use dynamic programming there. And then for pathfinding, someone's mic is on. Yeah, no problem. Okay, and then there are pathfinding algorithms like Bellman-Ford algorithm, and the scientist Bellman, I don't remember his complete name. This was Bellman-Ford algorithm for finding path in a graph where you could have negative weight edges. It's a very popular algorithm that is taught in, I think that you guys would also have heard about it. So
Yes.
their dynamic programming is used. And then obviously dynamic programming is heavily used for a lot of optimization problems as well. And this is one example where we're going to see. So have you heard about the game Rummy? I think you would have seen ads. It's a card game. You would have heard about it. Okay. So Rummy is a game, and I myself, I think it's been a very long time I played Rummy, but it's a game where you have to like remember about the cards that you have seen, and you have to put your cards in a particular sequence. Now, what they were doing is, this is taken from an article from ShareChat. Now, they were building an AI that could teach users how to play Rummy. And in order to teach users how to play Rummy, you need to like tell them what a you need to teach them like what is a pure sequence, what is a sequence, what is a set, what is invalid. Again, not diving into too much details into what this game is. Our goal is to understand like where did they use dynamic programming. So 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 if I give you a set of let's dial this problem down into a very basic one. If I give you this problem, like you're given an array of numbers and you have to find a subset that has that given sum. Heard about this problem, subset sum problem? Do you understand? Is my question clear?
Can you again tell the question?
Yeah, I'll just go in. So let's say you're given a list of numbers. You're just given a list of numbers, and you have to find a subset of these numbers that sum up to a given number.
Okay, yeah, got it.
So this is like a very popular subset sum is a very popular problem. It is again solved using dynamic programming. But anyway, if you guys have not, make sure to keep a note and check that problem as well out. It's a very popular problem. So anyway, coming back. So here in case of Rummy, you're given 13 cards and you have to like arrange cards in a certain way so that it becomes a pure sequence or a set, or if there's nothing, it's invalid. So while creating AI, they had to think about how could they between all these 13 cards given, they could make permutations of it and find out if there's a pure sequence or whatever. So obviously, brute force solution is to make all the possible combinations of three or more cards and see if there's a sequence or not. But the time complexity will go into the order of factorial, right? Because you have 13C3. So that will be very huge. So, and there's no point in even going out and trying out this solution. So there comes a very, like this is kind of an advanced solution to what they did was, but I'll link the article and I'll share this PPT with you guys as well after this call. I'll just share it with Ma'am. So they basically what they used was called dynamic programming with bit masking. Again, this is an advanced topic, not the scope of this discussion, but just wanted to show you that what they did was for all these sequences of card, they created a binary string. Now this binary string is also called as a mask. So your DP state there relied on something like a mask and the current status. So if you have a pure sequence or not and so on. So the DP state was dependent on mask and your current state. Now this mask could be encoding 13 bits. 13 values could be encoded in just 2 to the power 4. So 4 bits. So it could just be encoded in 4 bits. So the overall runtime complexity of this came very less, and they were able to solve this problem of finding all the permutations of and generating a pure sequence is there or not in very less time using dynamic programming. So
I want to ask,
again, yeah.
Why did they use, like we had learned bit masking in network and communication. So there that was basically being used for the network signals. Here, why can't you use just index of cards and you used like encoded it with a bit mask?
Yeah, so that's what so bits of so they encoded the current sequence of yes, so exactly. So the positions and the cards that they had, they encoded it. So every time you add a new card, they encode it as a new bit mask sequence. Now exact details of this is something I'll have to even go ahead and read it, but it was a fun thing that I found out. Yeah, so I'll just link the article as well. You guys can also dive deep into it, but this is an interesting implementation of dynamic programming where I saw. So, but that's a perfectly valid question. Yeah. So this is like so this is one place where dynamic programming was used. And when I read this article, I guess it was about 3 to 4 months ago. I read this article. It was really good to see that it's not always these longest common subsequence and LIS questions only where we see dynamic programming being implemented, and there are some problems. So again, if you if say Devansh already knows about bit masks, it gives him another dimension to think. Okay, why don't I model this as a bit mask, as it's something that can be coded as bit masks? Maybe that can reduce the amount of states that I have to travel to. So again, the goal of this entire small lecture was to motivate you to think in terms of why do you need to study this subject? What are the things that you keep in your mind so that they can help you to solve any problem that you face in future? And that was my goal. So yeah, I hope I have made myself clear over that. But anyway, before closing, I just wanted to talk about a little bit about problem solving in general. And so are you guys mostly in your second years, third years? Third years,
Third,
right? If I'm not wrong. Third year, right? So I think,
fifth sem.
yeah, so fifth sem. So you guys are pretty close to your placements as well. So so just wanted to quickly go through that as well, just to give you that knowledge, whatever I have regarding placement. So um, always like take whatever time you get after this semester, your summer. If it's your winter, okay. Okay, so placements start after the end of sixth semester, right? They start when seventh semester begins. So whenever you get time, so from now on itself, if you start problem solving. Now earlier I asked how many of you solve problems on CodeChef or do problem solving actively, and I could see very few hands. And that's not a good thing, because in the end, the one who solves, see, obviously I as a someone who's taking interviews, I don't ask questions like longest common subsequence just to check if you know the solution and you have crammed the solution already or not. I'll ask you a question which I've seen in my real life that involved an actual use of some data structure, where I'll see if you can actually think by extending the knowledge that you have already or not. And that is what your on-job work is going to be like. So, and to get at that level, first you need to understand all these basic problems that you have, the standard set of problems that you have. So if you're already not actively solving problems, make sure you do like CodeChef, take part in long challenges, take part in short contests, solve problems on code forces, form groups among yourselves. If you're doing it alone, why don't you share it with your roommates? Form a group. We used to, I think ICPC is going on as well this year. I'm not sure if one of you took part in ICPC. I think regionals are going on anyway. So that's so you could make a form a team of 3 people. You could just go to become good at it and go to ICPC. That's an experience overall, and it carries weight on your resume as well. When you say someone that you've been to ICPC regionals. So, but anyway, if you haven't gone, that's not a problem. But what I want from you guys, the only thing I want you to take away from this lecture is to understand the importance of this subject, the understand why you are being taught this subject, and this subject is like one of the basic subjects that you're going to carry forward again after you complete your degree in your life as well as a software engineer. These are basic skills. Anybody likes someone who can think of a problem quickly, and to think of a problem quickly, you need to have seen those patterns previously, and to see those patterns previously, you need to solve more problems. And to solve more problems, you have to get started now, so that by the time you graduate, by the time you become a software engineer, you have already have good enough experience so that you can just brag about that. Okay, yeah, this problem I know how this problem can be solved. Right. So that was all about that was all that I had to share with you people. So uh, questions, anything, let's anything that you have in your mind regarding whatever we discussed, regarding anything in the future, problem solving, anything. We'll just take 5 minutes and then we'll conclude this session. Feel
I want
free,
to ask,
don't be
in
shy.
industry, when they look to basically solve problems, which there are two places, two reasons why algorithm actually became so much important. The one is actually memory is not basically inexpensive, and the second thing is that you don't have an infinitely fast processor. So
Correct.
what do you basically look for? Do you look for a algorithm that actually saves your space much, or an algorithm that actually is able to solve problem? Because anyways, the one who is actually being using the algorithm is somewhere sitting remotely, and you have to send signals to them, right?
Correct.
So
So I'll tell you, as you said, memory is becoming inexpensive, right? So memory is a lot more cheaper than CPU power. And I'll tell you why. It's not like CPU power is getting expensive or anything like that. But if I am, let's say that example of fetching thousand entities at a time. Let's say there are 10,000 entities. I'm running a while loop. and I'm not using asynchronous nature of my programming language, what will happen is now I have enough memory. I have a lot of RAM. I have 32 GB of RAM in my laptop. But what can that RAM do if my program is just stuck on that part of the algorithm? That just cannot, like, even if I give it 32 GB of RAM, it's still using my CPU. Right?
Yeah.
So at that point of time, I need an algorithm where that can run fast, that can unblock my CPU faster. But obviously, like if you work on something like an embedded system where you have simple algorithms, but they require a lot of space. Let's say merge sort. Merge sort requires external space, right?
Yes.
Would you go on for using merge sort, or would you use something like quick sort or something other than that
Quick
based on
sort.
your needs? So exactly. So that's why knowing multiple sorting algorithms helps you in that case. So it's not always a question to ask, would you optimize for memory or would you optimize for CPU? Because depends on the scenario. And like one of you guys pointed out, right? You would have a button where you would uh, not need to use recursion or a while loop or anything like that. But that's not always possible, right? You'll not always have scenarios where one thing will always work. So that's why, like, depends on the case, depends on a case by case basis.
Another thing I want
So
to ask is like, so I read something like about Cisco itself, like they are trying to basically build a mobility solution where you can have a smart road system. So
okay.
let's say in Chennai, there are various places, Tambram, Kelambakam, and various other places, and Cisco is actually catering to them. So there is some place where they have actually got the contract in Australia or somewhere. I don't know that, but it's like different places, and the road system managed by so many places will be done through a single system. Like there are various people accessing the same cloud, various signals, various traffic equipments, and of course the monitoring devices of the traffic police, that will be done through a single source of information processing unit, which will be
Okay.
managed of course by Cisco. Now I want to ask, similarly we see various other solutions like in today's day of cloud age, right? Everybody is actually having a central processing unit. We are like communicating on Teams, and everything is happening in the unit of Microsoft. That processor is happening. So these things are actually like someone would have made a feature of Microsoft Teams like calendar. Someone would have
Correct.
made different features, and there are different people working. Different things will require different data structures, different kinds of program. So since you are in the industry, I want to know, like, since like I'm a programmer sitting on, I will code on a single terminal, I know what it is. How do so many people at different centers communicate with each other, and it is stored and embedded together as a single data structure, or I like to ask it, in a
Single
single
experience,
network
as a
of
single
program.
experience, as a single
Yeah,
experience, right?
because as a
How
viewer
it
I
comes.
see it as a single network that's being given to me, but I know that every component of my software is actually built in different data centers, right? So that's
Correct.
what I want to ask. How do teams
Okay.
communicate with each other?
How do teams communicate? Okay, so and that's not a technical question. I'll just answer you. So uh, obvious answer, teams communicate via meetings. And so and that's like, so let's say I'm working with on something, and let's say I work on a product that someone in Europe is also working on, someone in US is also working on. So we generally sync up, or we have documentation of things like this feature has to be created in certain way, and these are the things that it has to work on. It has to support these kind of functionalities. Now the overall vision comes from someone who's known as a product manager. Product manager defines, okay, the end user, the goal of a product manager is to give you a scope that we need to solve this problem that is faced by the customer. Then the product manager sits with the designers and the engineering manager to set up something like what can be done with the current product that we have. They all agree to something mutual, and then the designers design on how it should look, if that's an end user UI kind of thing. And then it comes to engineers. Now this engineers team can be distributed across, like my team itself, like we have some members in Europe and some members we are here in India. So, and Git, I guess you would obviously know. So we use like Bitbucket, we use internally to maintain our source code. But the communication point, obviously we get the mocks from the designer, and this product manager is the person who oversees everything. Like he acts as a customer, seeing that, okay, so product manager is not a technical person in generally speaking. So
Okay.
he acts as a customer and sees that, okay, overall the experience should look like this. And so we as engineers then, like, work with our managers and other teammates to break this big experience or break this big task into small modules where we all work towards completing single small features. These all features integrate together. Integrate together meaning that let's say if I'm using some kind of framework like Angular or Spring or React, I'll be writing some kind of components or something like that. It'll just integrate into the entire web application overall, and other teammates in Europe will also, and if there's some doubts or something, we'll have meetings, we'll sync up, we'll have internal documentation, we'll have internal wikis that'll keep track of what's going on, how it's being done. So it's more like how you would have, like, it's more of software engineering than actually doing something with programming. So it's the overall engineering itself. So once you join a company, you'll probably get more experience into like how this overall software is viewed and how do companies offer that entire experience.
So like currently when we work in projects, we use something like a Google Colab. So on the same terminal, various people can go. So do companies have that something?
Okay. So Google Colab is like a so generally developers don't work like on a same Google Colab or a same Google. So for example, what Google Colab is like, it's a Google Docs kind of thing, right? Where multiple people or exactly, it's like Google Docs. So, but in general, people don't like write code on a same thing. Have you guys heard about Git or version
GitHub,
control, GitHub?
Yeah,
You heard about GitHub, but Git? Okay, never mind.
It's a
I'll
way
just
to
let you know.
store your programs, right? And communicate.
That's
Command. It's built in line.
it's
Version control.
version control. Exactly, version control. So what version control means basically, and again, like we're going a little bit off topic, but it's okay. So it's like this. So very basic solution to what Devansh asked could be that, okay, I write a program and I just email it to you. Or I could just be using a Google Docs or kind of something like an editor that is like common for everyone. But then if two people are editing the same line at the same time, what will happen? How will you communicate that, okay, I have to make my changes here or I have to make my changes here? So there, what you use is something called as a distributed version control system. And that is what is Git or GitHub or Bitbucket. So GitHub and Bitbucket are basically the places where your central repository where your code is stored. So every person in my team checks out code from this central repository on their own local machine. They develop code, they add feature on their own local machine. Then they make changes to this code and push that code back into this central repository in the form of a request that, okay, I have made this change. Please merge this change with your central code. And then we all look at that code. What all have you changed? Is this good? Is the performance of this code good? And then only we approve, and then that code gets merged into the central repository. And then all of the other people can basically take that change, like pull that change in their own local machines. So this is how it works. So read more about version control systems and Git. You'll get a better idea on how to, or you can maybe Google on how to get started with Git or version control. So if you are, or maybe you can take help of your friends, right? You have friends in class who have used version control. Someone mentioned it. So talk to more people in your class. Google about version control. That's the solution to this problem.
Got it.
All right. Anybody? Anything else? Anything? Don't be shy. If there's anything, I'm here. Okay, ma'am, I guess then no questions. I'll take the silence as no question. I think we can.
Prakash, you made Siva Prakash to be quiet. He will be the most active student in my class. Siva Prakash, are you there?
I think,
Yes,
did he
yes,
feel
ma'am,
bad
I'm
that
there.
I told him
No,
not
no,
to
no.
answer?
It's all good.
Did
It's
you
all
feel
good.
bad?
After that, you became so
Sorry.
quiet.
Sorry.
Yeah, it's completely
It's very
fine.
good.
That's all.
It's very good. Yeah, I mean, you
Yeah,
had a lot of knowledge. It's very good. Very good.
Okay.
That's no problem. See.
Any questions, Shiva Prakash? I ask you specially because you
Yeah,
There's
yeah.
no,
keep
there's no
me
questions,
engaged in the
ma'am.
class. No
No, there's no
question.
questions, ma'am. Nothing else.
Okay, thank you.
Yeah.
Okay, thanks a lot, Shubham, for your wonderful lecture, and you made it interactive. That's great. I missed one point while I was introducing. He was also UTF for data structures and algorithms, right? He also now proved as a good teacher. I hope so, right? Okay. So anything else you want to tell anyone?
No, that's all. I mean, I hope I made myself clear, guys. I hope I see more participation from VIT Chennai in sites like CodeChef and Codeforces. I hope to see a team from VIT Chennai in ICPC as well. And
Yeah,
please,
they are
thank you.
already
Thanks.
Few
They're
students
already
are
I
part of
looked
it.
active.
for ICPC actually, And so
Yeah.
is it registrations open?
I think it's for this year. I think regionals have already started.
Yeah,
I think this year it's already, or maybe next year you can try after placements or something.
Okay.
But do give it a try. It's a worth it experience.
Yeah.